In this video, I'm going to show you a few examples of applying the chain rule for finding derivatives. And the chain rule is a great shortcut for finding derivatives of functions that look like a function within a function. So to illustrate what I mean, check out this first example. We have y equals 8x to the fourth power minus 8x squared plus 4 all raised to the fourth power. And notice how this function looks like a function within a function where the inner function is 8x to the fourth power minus 8x squared plus 4, and the outer function is something raised to the fourth power. To apply the chain rule to find the derivative of a function that looks like this, what we do is we take the derivative of the outer function, leaving the inner function alone. So by the power rule, we know that in order to find the derivative of this outer function, we would take the exponent down in front and then decrease it by 1. So that's what we're going to do when we apply the chain rule. We're going to bring that power down in front. We're going to leave that inner function alone. So I'm just going to rewrite it. And then we're going to decrease that exponent by 1. And then the chain rule says, once you've taken the derivative of the outer function using the power rule, then multiply by the derivative of the inner function. So we're going to multiply by the derivative of the inner function. Again, we're going to apply the power rule to do this, and we're just going to focus here on the inner function. And applying the power rule here would give us 32x to the third power minus 16x, and then the derivative of 4 is just 0, and we don't typically put the plus 0, so we just leave that off. And so our derivative ends up being 8x to the fourth power minus 8x squared plus 4 all raised to the third power times the derivative of that inner function, which is 32x to the third power minus 16x. And typically you don't have to take this any further. As you can see, this would be quite a lot of work in order to multiply all of this out and distribute everything. So as long as you include the parentheses where I have included them here in this example, your final answer would be as stated right here. So let's take a look at the second example. Notice we again have the situation of a function inside a function, where the inner function is what's in parentheses, which is 4x squared plus 7, and then the outer function is the negative 6, and we don't really care what's in parentheses, and then the negative 6 power. So again, this is a great example of where we can use the chain rule as a shortcut for finding the derivative of this function. So let's go ahead and do that. The derivative of the function would be, we're going to take the derivative of the outer function using the power rule by moving this power down in front and then decreasing it by 1. So I'll write that out here. So we're going to leave that coefficient of negative 6. We're going to bring the exponent of negative 6 down as a multiplier. We're going to leave the inner function alone, so I'm just going to rewrite it. And then I'm going to decrease that exponent by 1. And now the chain rule says to multiply all of this by the derivative of the inner function. So we're accounting for everything here. We're accounting for the outer function and we're accounting for the inner function. Everybody gets to come to the party. So using the power rule, we're going to take the derivative of the inner function, which would be 8x, and then the derivative of 7 is 0. So the derivative of that inner function is just 8x. And then we'll do just a little bit of simplifying here. Negative 6 times negative 6 is positive 36. Then we rewrite what's in parentheses. And then negative 6 minus 1 gives us a negative 7 power. And then we use parentheses and stick the derivative of that inner function there. And so your final answer is 36. And then 4x squared plus 7 all to the negative 7th power times the quantity 8x. And again, as long as you utilize parentheses where I've utilized them here, your final answer is good to go as is. So if you're having a hard time identifying which is the inner function and which is the outer function, notice that in our first two examples, the inner function is what's inside parentheses, and the outer function is kind of what affects those parentheses. As we move on to our third example, let me just give myself a little bit more room here. We have the function 8 square root of 7x squared plus 9. And so we have a very similar situation as the first two examples, and it might be easier to see that when we rewrite this example using parentheses and an exponent. So remember, we can rewrite a square root by taking the radicand to the 1/2 power. So I can rewrite this guy as f of x equals 8 and in parentheses 7x squared plus 9 all raised to the 1/2 power. And then we have a situation that looks very similar to the first two examples, where our inner function is what's in parentheses, or what was under the radical. So 7x squared plus 9. And then the outer function is 8. And then we don't really care what's in parentheses. We've already accounted for that in the inner function. And then that raised to the 1/2 power. So to find the derivative of this, the chain rule says we're going to take the derivative of the outer function by, we're going to leave the 8 there, we're going to bring that exponent down as a multiplier, and then decrease the exponent by 1. So we have 8 times 1/2. We leave the inner function alone, so 7x squared plus 9, and then we decrease that power by 1. And then by the chain rule, we're going to then account for that inner function. So we're going to multiply by the derivative of the inner function, which by the power rule is 14x, and the constant of 9 has a derivative of 0, so 14x will take care of it as far as the derivative of the inner function. And then we'll just clean this up a little bit for our final answer. 8 times 1/2 is 4. Leave that inner function alone. When we decrease our exponent by 1, we get negative 1/2. And multiplying by the derivative of our inner function, 14x, gives us our final result. So think of the chain rule as taking, first of all, identifying the inner function and the outer function, and then the chain rule accounts for both of those by taking the derivative of the outer function, leaving the inner function alone, and then multiplying by the derivative of the inner function.